Hello student, welcome back to yet another video on our channel which based on the linear differential equation with a constant coefficient. I already started a simultaneous differential equation, how to solve the simultaneous differential equation when we have the form dx by p which is equal to dy by q which is equal to dz by r. Okay, such a form I already explained what is the method behind of this. If you want to see this method, check in my previous lecture. Okay, I already uploaded that. So in my today's video, I'm gonna explain to you all some of the example based on the simultaneous differential equation. Okay, yes, symmetrical simultaneous differential equation by using variable separation form. Okay, variable separation form also I explained in my previous lecture. Okay, so in my today's video, I'm gonna explain to you all this example. These are the important example, guys, for your perspective of the SPPU exam. So be carefully, these are the easy example will give you all very easily marks. Okay, yes. Okay, now see that as we have this differentiation, let's start the question. Okay, dx by y square z divided by x square z plus dz by y square x. Okay, as we have this question, so we compare any two ratios. Okay, any two ratios like a dx by p which is equal to dy by q, or dy by q which is equal to dz by r, or dx by p which is equal to dz by r. Anything you can compare, it is completely up to you. Okay, so I'm going to compare dx with the dz. Okay, I'm going to take another ratio, so I'm going to compare dx with a dz. Okay, dx with a dz. So first two ratio means dx by y square z, okay, and dz by y square x. Why I consider? Because see that those are the possible term to get cancelled here. Now we have y square, so easily we can solve. That's why I consider y square as a similar term for this two denominator. Okay, yes. Now what do we do? Similar term cancel it here first. Okay, now we have to apply variable separation form. Okay, dz has a denominator x, dx has a denominator z, so take their respective differentiation. Okay, x into dx, I'm going to write x into dx, z into dz. Okay, x into dx which is equal to z into dz. I'm going to write this step is like this. Okay, now see that we have dx and dz which is present over here. Take the integration for both sides and solve these terms. Okay, so we write integration of x dx which is equal to integration of z dz. Okay, yes, integration of x with respect to x, we write x square by 2 which is equal to integration of z with respect to z square by 2 plus c. Okay, consider this one is a c1. Okay, we have want the two different solution, that's why I'm taking. Okay, so what we want, we want the value for c1, so take this term here, x square by 2 minus z square by 2 which is equal to c1. Okay, I'm going to write this one as x square by 2 minus z square by 2 which is equal to c1. Okay, yes. So what we have here, two denominator common here, take to the outside, other side. Okay, x square minus z square which is equal to 2 times c1. Okay, x square minus z square which is equal to 2 times c1. As I told you all, constant we have always same in our differentiation. Okay, 2 times c1 I'm going to write is only c1, so x square minus z square which is equal to c1 only. Okay, this one is our first solution. Okay, this one is our first solution. I hope you all have understood my first solution. Okay, f of x y z which is equal to c1. Okay, now we have to work for f of x y z which is equal to c2. Okay, so you can compare any two ratios here. Make sure that we have to cancel similar terms. Okay, so which we are going to consider. So we can see that dx and dy, if we consider dx and dy, so what we have, z can be cancelled from here. Okay, so consider first two ratios. Okay, this one is our first solution. Let's go for the second solution of this differential equation. Okay, so I'm going to consider dx by y square z, dx by y square z. Okay, dx by y square z which is equal to dy by x square z. Okay, this one is our next solution I consider here. Okay, so what we have, z common, cancel it from both sides. So as we want the variable separation form, so take similar term with the similar differentiation. So x square with the dx. Okay, then x square with the dx and y square with the dy. Okay, take their integration in order to remove dx and y. So integration of x square dx which is equal to integration of y square dy. Okay, so what I have done, I applied only the integration to the both side. Okay, so integration of x square is a x raised to 2 plus 1 by 2 plus 1, that means x cube by 3 which is equal to y cube by 3 plus c2. Okay, as we have already c1. So take this term out here, x cube by 3 minus y cube by 3, which is equal to C2. 3 take it to the other side, x cube minus y cube, which is equal to 3 times C2, and 3 times C2 which behaves same in our differentiation. Okay, so I'm going to write x cube minus y cube, which is equal to C2. Okay, now see that I got the two different solution, f of xyz which is equal to C1 and f of xyz which is equal to C2. Okay, so f of xyz which is equal to C1 and f of xyz which is equal to C2. Okay, this we have two linear differential equation, two simultaneous differential equation with a constant coefficient. Okay, now see that we got the first solution f of xyz c1 and f of xyz c2. These are the two solutions for our simultaneous differential equation. Okay, I hope you all have understood my today's solution. It is not that difficult, guys. Need to apply only the variable separation form. Okay, it is way easier to apply the variable separation form. For your reference, you can refer my entire solution over here. Okay, so I hope you all have understood my entire solution. Okay, it is one of the easy methods, easy calculations, gives us very easily marks. Okay, I hope you all have understood entire my today's lecture. Even after, if you found anything difficult, confusing, let me know, guys. I will come up with the similar videos. Or if you are interested to see similar more videos, let me in my comment section. Or you come across any challenging part in mathematics, let me know, guys. I will come up with their solution also. So thank you everyone. Thank you for my today's lecture.